Okay, picking up on our discussion of beta, again, beta is a measure of systematic risk. So in this case, we have the four different securities that we were looking at earlier. Again, we have Citigroup, Coca-Cola, Intel Corporation, and BP. Earlier, we went through and computed the weights associated with this portfolio. Now it's time for us to compute the portfolio beta. So to compute the portfolio beta, it's kind of similar to how we computed the portfolio expected return. So to compute the beta for the portfolio P, we'll take the weights associated with each stock, multiply that by the betas associated with each stock, take those weighted probabilities, multiply it by the betas, and then add them all up, and that will tell us the beta for the portfolio. So for this one, it would be 0.133 times the beta of stock C, which is 1.685. Go to Coca-Cola, which has a weight of 0.2 times a beta of 0.195, plus the weight of Intel, which is 0.267 times the beta of 1.161, plus the beta of BP, the weight of BP, which is 0.4 times the beta of BP, which is 1.434. Okay. So from here, just plug it in and solve for the portfolio beta, and you should get 1.147. Okay, so altogether, this portfolio has a beta of 1.147. The question for you is, this particular portfolio more or less systematic risk? Does it possess more or less systematic risk than the overall market? We'd say more, because the beta exceeds 1. Okay, now a couple of things that we need to pick up in terms of finishing up the chapter. You need to know that there's something that's called a risk premium. If you're taking on an asset that contains some type of risk, you need to be paid a premium for taking on that additional risk. And we often refer to that additional risk as the risk premium. So what we do is we take the expected return on a risky asset, and then we subtract out the return on a risk-free asset. The risk-free rate is often proxied using the T-bill rate. When I say T-bills, I'm talking about Treasury bills that are issued by the U.S. Treasury. They're basically risk-free because the federal government can't default on them, but they carry very low returns. So the T-bill rate is what we typically use. And then the expected return over here would be the expected return on any risky asset in the market. That said, as we know, if the stock has a higher beta, it's going to have a higher expected return. Therefore, the higher the beta, holding the risk-free rate constant, we should have a higher risk premium, because the expected return will go up if we have a higher beta stock. So, can we define the relationship between the risk premium and beta so that we can estimate the expected return? The answer is absolutely, we can. Now, what you're going to see here on this graph is kind of outlining what we would typically expect between returns and beta. As you know, it's kind of a linear function. It's a straight line that, as we increase beta going left to right, what happens to the expected return? It mechanically or linearly increases. Okay, so for example, in this case, if beta is between 1.5 and 2, let's call it 1.75 or 1.8, the expected return would be something close to 21, 22%. Okay, now what actually gets us this line right here? Okay, so there is something called the reward to risk ratio, and we refer to this as the slope often when it comes to that linear line that I just presented to you. Now, I don't want to really focus too much on the slide. If we were to, in equilibrium, show that all assets and portfolios should have the same reward risk ratio, they must all have equal the reward to risk ratio for the market. Okay, again, this is some derivation that I don't think is necessarily useful for this class. That said, we do have something called the security market line, which is a representation of the market equilibrium. The slope of the security market line is what we refer to as the reward to risk ratio, and it's given here as the expected return on the market. So ERM is the expected return on the market, less the risk-free rate divided by the beta, or the beta for the market. Since the beta for the market is always 1, you basically just know this is 1, and therefore anything divided by 1 is itself. So this just carries down to here, such that the market risk premium, okay, is going to be the expected return on the market, so ERM minus RF. Now, one last thing that we need to account for is this model right here, which kind of puts it all together. Okay, so to compute the expected return for any stock, we use this model right here. It's called the capital asset pricing model. It was developed probably in the mid-early 60s, so it's been around for 55 years. How do we compute the expected return for, say, a risky asset called A? Well, we take the risk-free rate, whatever that is. Okay, usually we use the T-bill rate, plus the beta for that particular stock, so beta for stock A, and then we take this, the stock's beta and multiply it by the market risk premium. And again, the market risk premium is what's in the parentheses right here. So it would be the expected return on the market less the risk-free rate. So again, this is the market risk premium. And sometimes we call it RPM. Okay, it's, again, the market risk premium is simply the difference between the expected return on the market less the risk-free rate. Thus, if we know the asset's systematic risk measure, which is going to be proxied by beta, we can go through and determine its expected return. So if we look at this particular chart here, hypothetically, let's say we had 4 different stocks. So we had Johnson & Johnson, we had Twitter, we had Tesla, and we had CBS Corp. All right. If we know that the beta for each stock is given to us, and we know that the risk-free rate is measured as 3.15%, and the market risk premium is 7.5%, we can go through plugging these values into the CAPM and solve for the expected return. Okay, so again, it's the risk-free rate plus the beta for the individual stock times the difference between the expected return on the market and the risk-free rate. And we know that difference is the market risk premium. So I'm going to write RPM here. And we know that the risk premium is 7.5%. So that's where we get the 7.5 at. We know that the beta for each stock is given to us in this particular column. And then the risk-free rate was given to us as 3.15. So plugging those numbers into the equation, you should get the following expected returns. 8.18 for Johnson & Johnson, 9.53% for Twitter, and then so forth. Now you notice the higher the beta, the higher the what? The expected return, which is why we call the CAPM a linear model, a linear equation, because as we increase beta, it's going to mechanically increase the expected return on a linear basis. It's going, up and up and up and so forth. So that is the CAPM, and that's how we compute the expected return for an individual risky stock. And that wraps up Chapter 13. The next video we will touch on Chapter 8.